Thank you. Yes, so we're not doing the advertised topic today that you'll see in the program. We're going to talk about the clicker. Could I have the clicker, please? It's here. I apologise. Okay. All you really wanted to hear about today was another vendor talking about the convergence between HPC and AI, wasn't it? Okay, so I'm not doing that. I wasn't sure I could actually give this talk. I only got the slide set on Friday. So that's the situation there. And let us talk a little bit about this. Good, I can drive it correctly. We've heard a lot about the exascale programs of the various countries. We hear a lot about the exascale, I'm going to get that right, exascale program of the United States. We hear a lot about the exascale program in China. We hear a lot about the exascale program in Japan. There is a fourth exascale program, and is the one known as euroHPC. And the European Processor Initiative is about providing the processor for the euroHPC exascale program. Now, there's been a lot of talk about headline numbers for exascale, getting to 1,000 petaflops, essentially. The situation is that the euroHPC exascale program takes a very different philosophy from some of the other programs. It's really about putting in place a system, in fact 2 systems in Europe, where the capability of exascale is usable. Okay, so it's about getting a usable exascale, not hitting a headline number. All right, now hitting a headline number is attractive, but having something that we can really make use of with real-world application performance is where the focus is in the euroHPC program. So the European Processor Initiative is very much focused in the first instance on the high-performance computing needs of the euroHPC program. However, it will be an unsustainable program without having some other components brought to bear in order to be able to fund this initiative and have it be self-sustaining. So one of the other key parts of the European Processor Initiative is autonomous driving, okay? And we read a lot these days about autonomous vehicles, okay? And the European Processor Initiative also looks at low-powered CPUs for servers and cloud in general. So there is a very particular focus in the euroHPC program and hence in the European Processor Initiative on low-powered processors. Now let's see if I can get this to work. The EPI is a consortium of 23 organisations. Now did we just, there we go. You notice that we have our friends at BMW here, okay? Some significant names in the HPC community, places like Jülich, Barcelona, people who do chip design, people like Infineon, ST are in here somewhere, ST Micro, okay? So the consortium brings together the intellectual property in order to be able to both build the processor and deliver that processor into the euroHPC program. And I did the off thing like everybody else has done. So the goal or the mission of the EPI is to achieve European independence in high-performance computing technologies. Okay, so they are not beholden to organisations from other parts of the world in order to deliver the exascale machine. And the time frame that the Europeans are working towards is 2023. But importantly, it's based on a solid long-term economic model. Okay, this isn't a single shot in the locker. It's not, of course, given the events of the last week, all single-use prime ministers are banned. Okay, so are single-use processors. Okay, so the vision is to develop a European-made family of high-performance processors for the euroHPC, for connected mobility and autonomous driving. And the interesting thing is that the program is designed in such a way that as the Exascale program in the first instance has been achieved, the autonomous driving vehicle piece picks up. Okay, so that's how we build this sustainable model, and there are other markets under exploration. So the idea is to leverage synergies, both financial and technical, between the different markets. Okay, and you've probably seen in the literature some of the discussions about, to get to true autonomous driving, how much compute power needs to be in the car. It's not entirely obvious in the first instance the compute requirements of autonomous driving, but they are substantial. Okay, so the situation is that as the EPI gets built out, it will be built out for that Exascale program in the first instance, which will naturally then lend itself to the autonomous driving piece second. Okay, so what this does is it allows for a wide market coverage of the EPI on a sustainable economic model moving forward. The first targets, the core developments, are for the European HPC and the autonomous driving component, and as I mentioned before, under investigation is the server and cloud piece for low power. We then add in, importantly, the thing that's so hot right now, which is artificial intelligence and big data, but then importantly, looking at things like Industry 4.0, and especially given that that Europe is still a very strong market, strong in manufacturing, let's just put it that way. Safety critical components in both Industry 4.0 and robotic process automation, and importantly space as well, is a future application for the components of the European Processor Initiative. Here's a roadmap. There are two key existing technologies that are being brought to bear in this roadmap. Firstly, you'll notice that there is, now the pointer light doesn't want to work. Ah, there we go. Is ARM, and there are many developments in HPC in ARM at the current time. But importantly, we're also making use of RISC-V as well. Okay? The difference is that RISC-V is not focused on the CPU component, it's focused on the acceleration component. Okay? So we are bringing together both the technologies that we can get from ARM and from RISC-V specifically as an accelerator. So this basically means we're looking at a 2020-2021 time frame for the HPC chip and system and the accelerator chip and system, so that in the 2021-22 time frame we have a pre-Exascale system and an automotive CPU proof of concept available. The idea is that we're looking at tape out for those particular processors towards the end of 2019. The next generation is the generation that the euroHPC Exascale system will get built from. Okay, and we see that that's in a 2022-2023 time frame. So the genuine euroHPC Exascale system is targeted at 2023, and that will have genuine automotive CPU product deployed in vehicles in the 2024-2025 time frame. Okay, so EPI started off with 7 core partners. You'll notice that one of them here is Bull, okay? Bull being an Atos company, 80 years worth of heritage in the information processing industries. Atos acquired the Bull organisation in 2014. You'll notice that there are other key organisations inside there as well. You might not be able to pick that up. That's the Barcelona Supercomputing Centre's logo. You might be able to pick up Jülich. That's Infineon. Infineon being a Fabless design company. So the Commission, the European Commission, provided approval for the project towards the tail end of 2017. Okay, extra partners and lead customers have come on in the first part of the year. EU funds have started to flow into the project literally about now. Draft architecture specs and technology choices are being made at the current time. And you may recall, I noted this already, first tape out happens towards the end of 2019. Okay, so some updates on that program. So the European Processor Initiative General Assembly was first held on March the 23rd this year. Atos elected as chair of the board, and Philippe Noten, and you'll excuse me, I did German at high school, so my French is terrible, okay? Or in German, it's schrecklich. Was elected as the general manager of the EPI. The next formal milestone was there was a budget presentation of the Commission on April the 26th, and a NewCo, a new company, was set up. I don't know that NewCo's inherited a name yet, okay, and it's going to be set up, and I'll show you how the funding all flows in a bit, with €100 million of private funding and €120 million of public funding. And the EPI project formally kicked off very recently on the 1st of June. And I mentioned previously the idea is that the tape out would be towards the end of 2019, with first production in the first half of 2021. Okay, so given that the European Process Initiative flows into the euroHPC project, how is the euroHPC project being funded? Well, it's being funded by €1 billion to build 2 world-class exascale supercomputers. They're being a precursor, just like everybody else, exascale system in the 2021 timeframe, with a genuine exascale system in the 2023 timeframe. There are links to all of this in this presentation, so when you, I think the presentation winds up on the HPC Advisory Council website, you'll be able to go and see this information for yourself. There's been a lot of news coverage about this in the first half of this year, in Premier magazine, okay, about both the euroHPC initiative and the European Processor Initiative. And Thierry Breton, who is the CEO of Atos, spoke about this in May, and that also received a lot of press coverage at that particular time. This is the mechanics of how the European Processor Initiative works. The 23 partners are all up there, okay, have €120 million invested in them by the European Commission. That's been secured. The NewCo gets set up, okay, and that's a Fabless design organisation, and that's where the €100 million of private funding comes from, okay. The situation is that the EPI licenses to NewCo its IP, and the NewCo provides back to the EPI, okay, its progress, its key performance indicators, its audited results and control. And then the IP is then licensed to the industry so that any particular organisation can then make use of those processes and sell them into the marketplace. And NewCo then sells those chip sales into people who are building systems for artificial intelligence, big data, intelligence, supercomputing, automated driving, etc. Okay? And then the royalties flow back to the EPI consortium. All right? And then reinvestment can then potentially occur from there. And that bit on the right-hand side of the page continues to be a work in process. It's only the stuff on the left-hand side that has occurred at the current time. All right. So, it was back in April 2016 that there were the 2 EU declarations made about the euroHPC project, looking to foster an HPC ecosystem capable of developing new European technology with a focus on low power for the processor. Okay? Acquisition of 2 co-designed prototype Exascale systems in 2020. And the idea is that at least one, based on European technology, will rank in the top 3 of the world. So the Europeans are squarely setting their sights on taking on the Americans, the Chinese, and the Japanese in this space. All right, and the 23 partners are from research to industry. We notice, for example, the BMW group, and it is only because of the other use cases beyond HPC that the concept of a genuine European processor even makes sense. Because without those other use cases essentially funding the chip sales and funding the development, okay, then just the euroHPC initiative will not make the European processor initiative stack up. And one of the suggested names for NewCo is EPI Semiconductor. I don't know that that's actually stuck at the current time. And that's the Fabless NewCo that we were talking about that will be incorporated by the EPI members and external investors. So, the EPI Common Platform breaks out in this particular way, either based on the EP271 family in the 2021 timeframe, which we saw in that earlier roadmap, being the first generation of processor, or the EP272 family, which is the production Exascale system and the production automotive CPU. The first family being targeted at the pre-Exascale systems, okay, and that's where the pan-European research platform for HPC and AI will come to maturity for the Exascale system that will come several years down the road. Okay, so to zoom in on the common platform, the first generation, you'll see that the EP271 will make use of RISC-V for the accelerator, and will make use of RISC-V for the hardware root of trust, and will make use of RISC-V for the power domain controller. Okay, winding up in that pre-Exascale system, the pan-European research platform, which are different. They are 2 different systems. One is cloud-based, one's HPC-based, and the automotive CPU prototype. And at that point, that's all I can tell you at the current time about both the European Processor Initiative and the euroHPC Initiative. I'd be delighted to take any questions if you had any. Up the back here first.
Well, it's actually 2 questions in one. So the first one is, given they're using the same chips, what is there to stop a group of the autonomous cars driving to the same location and turn themselves into an exascale computer?
Well, Skynet will take over, won't it? Yeah.
The reason I ask that question is in the way you envisage the fabbing of these being done, will the exascale one be a crippled version of the automotive one and vice versa? So will somebody be able to take one of these chips and repurpose it for both?
No, I think the best way to think of it is it's more of a question of common platform design with variants on top of it, in exactly the same way as we think of that in traditional vendors' processes. Okay, so you know there are different. While the design is common platform in the middle, the variants that you have out on there, you know, some are suited for laptops, some are suited for HPC. Okay, it's the best way to look at it is that way. There was another question in here. Sorry, no, I think we're up the back here.
Yeah, so I'm a bit surprised that there's only BMW group in there rather than a number of the other European car manufacturers. Why is that?
I don't actually know. I know that, I specifically know from my previous employer that they had partnered with Audi, okay, so that they weren't. I know that there are ongoing talks with whatever the parent of Mercedes-Benz is the Daimler-Benz group, okay, at the top level, okay, about them joining, okay. But yes, you would think having BMW alone would not be sufficient, okay, and that a greater critical mass in the autonomous driving piece would be required beyond somebody than just the BMW group. Now, there may be other mechanisms that I don't know about that are going on in the background that sees them participating in different ways. Okay, but yeah, it's a valid observation. Just BMW alone, I wouldn't have thought that. I know that, for example, BMW make use of Bosch components, and Bosch components are designed by Infineon. Okay, Infineon are in the loop, BMW are in the loop. It to some extent almost squeezes Bosch in the middle. Okay, and Bosch supply to a whole range of people. So maybe that isn't as much as an issue as it might otherwise be presented by looking at that slide set. There was another question in here somewhere, down the front.
I want to know, did you do some analyze why you choose like ARM plus RISC-V for next European Exascale CPU, not choose like x86 GPU?
Okay, so the situation is that this is about European independence from other process vendors. The RISC-V instruction set, as you may well know, is open source. Okay, so there's nobody that they're dependent on for that particular technologies. I assume the reason that that ARM has particularly been landed on is from the low power perspective. I don't know, I'm guessing there. So the reason that they're looking at the combination of RISC-V and ARM for the low power piece, RISC-V because the technology is open source, which means that they can bring this together in such a way, okay, that is genuinely independent from any other vendor. Okay, so it's to some extent the technology choice is driven by intellectual property requirements, okay, rather than this is the best technology. That is not to suggest that in any way there is any issue with ARM technology or RISC-V technology, but they're the building blocks that are readily available. Question here.
What kind of power range are you aiming for? So roughly 100?
So the situation is that the generic term low power is used. Okay, in the presentations I've seen over the last couple of days, people have been throwing up slides where things have 250 watts, 260 watts, 290 watts. One would assume that people are looking in the low hundreds, okay? Especially given the type of systems that we're talking about, but that is an assumption. I don't know. All I can tell you is it's low power, okay? Because, if we think about it, the Summit system at the moment, it's got to be 5 times bigger okay, to get to an exaflop, okay? You can't do that with the current power, well, meaningfully, okay, with the power envelopes that are currently being required for that. If you don't do something about the power of the processor technology, we have a fundamental scaling problem. Any other questions, folks? Sydney.
Can you come to Spain on the 21st?
Oh! Sydney, I like you more and more each day. Valencia, even better. I'll see if I can get Jean-Marc Denis to come over for you. But failing that, yes, I'd love to come over. Okay, thank you very much for your time. Oh.